Hey guys, welcome back to another video. Today we're going to be solving LeetCode number 128 on the DervCodes channel. This is, I believe, the 6th question from the NeetCode 150 list that I've explained, and let's get going. So, the question says, given an unsorted array of integers nums, return the length of the longest consecutive element sequence. So a consecutive element sequence is essentially a sequence, well, it is what the name suggests, but it's a sequence of elements such that the next element in the sequence is just the previous element. So the next element would be this, the previous element plus 1, so 2, and then the next one would be 3, next one would be 4, and that's essentially all that a consecutive sequence is. So if we look at example 1, in this case, we'd be looking for the longest consecutive sequence. So we have a 1, a 2, a 3, and a 4. And there's no other sequence that's actually longer than this one. So what we would do in this case is just return 4, since that would be the length of the sequence. Also, we must note that the algorithm should run in O of n time, so that means no sorting. Alright guys, so now for the solution. So let's consider the array in example 1, and let's just say we wanted to find the longest consecutive sequence. Well, what we could do is we could go through each element in the array and check if the element that would come right after it in a sequence is there, and then we could just keep a maximum variable, right? And update that each time we find a new sequence. Now this solution is a bit naive because it could get the runtime could get really bad really quickly. Now instead, one way to optimize our solution would be to use a hash set. So first thing we do is we keep an element set, so L we'd call it, and then this would just be a set of this array. And this would just make it easier for us to tell if other elements are in the array. So we wouldn't have to first iterate through to see, okay, well, is 101 in this array? Well, we just check the whole array, which has terrible runtime. So instead we use a set for that. Okay, but now is this O of n runtime like the question asks for? Well, actually, it's not O of n runtime. Because if we encounter a situation like so, well, in this case, what we would be doing is once we hit the element 1, we would be looking in the visited set for a 2, and then for a 3, and then for a 4, and then for a 5. And of course, we would find them. And then once we hit element 2, we would be looking for a 3, and then a 4, and then a 5. 4, 5, 4, 5, and then 5, we'd be looking for 6, we wouldn't find it. So this right here is n squared runtime. Now, to optimize our solution, what else could we do? Well, actually, what we'll notice from the example that we drew out right here is that, okay, well, why should I visit 2 if I don't need to, if there's a 1 in the set, because obviously that's lower than 2. What's the point? Same thing with 3. There's a 2 in the set. Why would I visit it? 4. There's a 3 in the set, so obviously the sequence would be something like 3, 4, 5 at the very least, right? So then we could use this to our advantage. Now let's see what happens. Now instead, all that we do is we check, okay, well, is there an element that would be part of a consecutive sequence that is smaller than a certain element. In the case of 1, there's not, so we look for the longest path. In the case of 2, there is, 3, there is, 4, there is, 5, there is. Now, once an element is part of a path, we'll hit that element at most twice. And by hit that element, I mean it will be part of some iteration of some for loop. So the reason for that is because if it is part of a sequence like this, then what will happen is there will be an element that is smaller than it. unless it's the very first element in the sequence. And then for the very first element in the sequence, we hit it only once because we only look for it as we pass through the array. Like so. There's no need to check if it's part of a sequence because it would be the start of the sequence. Also, it's important to note that duplicates are possible, so we could have something like this. So in this case, we just keep another set to keep track of the elements that we've already visited. So a visited set, and if it's already been visited, we don't want to visit it, just to make sure that we have that O of n runtime. And of course, this is still O of n space, since all we're doing here is we're keeping some set. We're going to keep some maximum variable to keep track of the maximum length consecutive sequence, and we're also going to keep a visited set, still all O of n space. Alright guys, so for the code solution, what we want to do first is we want to convert the nums array into a set. So we'll say nums set is equal to set of nums. Furthermore, what we'd like to do is keep a visited set. Visited is equal to an empty set. And then from here, what we'd like to do is we'd like to just iterate through the nums array. So for num in nums, what we'd like to do is first check if there's a smaller element than this one. So num -1 in nums set, then continue. Furthermore, if there exists the same element in the visited set, obviously we don't want to recompute this maximum. And of course we should have a maximum variable just for the maximum length sequence. Okay, so now what we'd like to check is, well, is this in the visited set? So if num in visited, then we just want to continue again. Otherwise, we're good to start keeping track of the length of the sequence. So let's do that. So we could say something like cur length would be equal to 0. And then what we would like to do is we would like to continue updating the value of the current element that we're considering in the sequence. So while num plus cur length is in nums set, what we'd like to do is we would like to update cur length, so cur length plus equals 1. Furthermore, after we've done these two checks, we'd like to add this element to the visited because we know that it's one of the minimum elements in a given sequence. So visited.add num, and at the end we want to take maximum to be equal to the max of cur length and maximum. And then in the end, what we like to do is we just like to return the maximum. And we can run our code, and as we can see, it is good to go. Alright, and that is all for this video. See you guys in the next one. Peace.